So there are three basic encoding techniques. So the three basic encoding techniques, these are like the foundation techniques, and we'll be having an example on the different digital data to analog signal techniques, which include amplitude shift keying. So amplitude shift keying is basically, it depends upon the amplitude difference of the carrier frequency. So in order, when we are converting, we need to consider that when the amplitude is high, when the amplitude is low, and we'll see an example. And so it's the difference of the carrier frequency. So in the amplitude shift keying, either there is availability of the carrier or there's no availability of the carrier. So we'll see how an analog signal is interpreted using an amplitude shift keying. And then we'll see frequency shift keying. Frequency shift keying is basically when there is a difference in the frequency of the signal. So for a 0 and for a 1, we may have different frequencies in frequency shift keying, whereas in amplitude shift keying, for a 0 or a 1, we may have, it could be determined with the presence of a signal and with the absence of a signal. Whereas in phase shift keying, the zeros and ones would be represented by a change in the phase of the signal. So I'll show you an example, and once you get to understand this example, then I'll give you an example that you will work on. So over here we have a digital signal, which is 0011010010. So over here we can see that with 0 it's represented as a straight line, and then for 1 it is changing. So it's going from 0 to 1 over here, and if we continue, if the next signal is a 1, it still remains, and when it goes to a 0, it actually changes and it goes up. And whereas when we go back to the 0, then in that case it goes up again, and when it's 1 it goes down, and then for the zeros it remains same, and for 1 it goes down, and for the 0 it goes up. Yeah, so we got a question, what is parameter? Parameters basically, as I discussed, based on different parameters. I can't remember which context I said it in. Basically, the different parameters are used. It can be an indicating point. So it can be a function. So it's basically, it could be a characteristics. It depends upon the context in which we use the word. So going back to the signal, we have 001101000010. So this is our digital signal. And over here, what we have done is we have converted this signal into digital representation. So we have the digital representation over here. So if we were to convert this into amplitude shift keying, and as I mentioned earlier, in amplitude shift keying, the 0 is shown as an absence of the signal, whereas 1 shows the frequency cycle. So as we can see that in this diagram, it's showing that when the signal is 1, the wave goes through 2 frequency cycles. This representation could vary. In certain examples, you may be given an example where instead of 2 frequency cycles, only 1 frequency cycle is used. So both are correct as long as you're consistent in your representation. And then we have binary frequency shift keying. In this, we can see that wherever the signal is 0, the frequency is half of where the signal is 1. And whereas in the binary phase shift keying, we can see that the signal starts, and whichever wavelength it is following, it will continue with that. unless there is a change in the signal. So as we can see that we're starting off from this point over here, the wave continuously continues its pattern because we have two zeros. Then at a 1, it is changing its phase and it is moving forward. And then again, when the 0 occurs, it is changing the phase again. So this is an example of phase shift keying.
The Victorian Institute of Technology has other great videos covering many different topics. Please check them out, and thanks for watching. Remember to like and subscribe the video for more great content like this.